who will present using the ETC together with P1 to actually prepare a proposal.
Hello. So, yes, I'll go very quickly through the P1 interface and through the ETC interface to try to put everything together. So, let me open and share. So can you please confirm that you see my screen?
Yes, we see the user portal login screen.
Perfect. So that's where it starts. So you really need to have a user account and to log in into the P1 system. So you connect with ether.org/P1 to connect to the P1 system, or P1 demo for the demonstration. And let's start. You can create a new proposal. Can someone confirm whether you see my cursor or not? Depends on the setup.
Can you move it? I think not. It seems not.
Okay. So when I really need to show you something, I will bring this stupid little red square that you should be able to see.
Yes, that
okay. So let's go, and this will be a simple one. So demo P1 for users. That's the title of your proposal, so make it sexy. You select the cycle, and we're going to submit a real proposal, not a DDT proposal. And proposal type, I keep normal for this. As Dimitri said, you need to read the call for proposal to make sense of which is what. Okay, so what you see here is on the left, you have this menu with all your proposals, and for the proposal we are working on all the various steps. Each line here opens a page in the main section. What is really useful is this checklist that you see. We have just created the proposal. It's empty, so there is a lot of things to do. But until you have addressed all these issues, you will not be able to submit the proposal. This summary page will be populated with all the information that you put in the various sections. So let me go first to the first section here on the left, and I will go to title and abstract. Title, as I said, it's the title of proposal, so you should make it really interesting. Abstract, same thing. Dimitri stressed how important it is. You just type. You notice that on the top of the screen there is a big red star. As soon as the star is gone, your text is saved. So there is no save button. Also, I want to show you here on the right, there is this button that lets you type in special character. That's quite useful for the scientific text. Sorry, no superscript, no subscript. That's not possible in this. Okay, this scheme is valid for all the text files that we will have in the proposal. The next thing that you want to go, next step, is the category, and I'll just pick one. Then the investigators, and here at this stage I'm the only one. To add someone, I just need to type the email in the top right box. So let's try. Yes, you see that you have to type the complete email address of your co-I. So in this case, I will add Nando, and I add him as a co-investigator. If for some reason your Dimitri Gado, your colleague does not appear, it might be because they don't have a user account, or you get the wrong email from the user account. You do need to have them in there to add them as a COI. If they are not in the portal, if you don't have the right email, it's not going to work. So I add Dimitri, and I add Dimitri as a DPI. DPI has exactly the same privileges as the main PI. Okay, I can edit the roles if needed. Note that by adding them, I notified them. Both Dimitri and Nando have received an email. Next step is the science rationale. You don't edit it directly in the proposal. You're going to edit it elsewhere and then upload the PDF. For the proposals, we have all kinds of templates available. So if you click on Google Doc, you have the various examples that you can that you can copy to your drive and then edit. Note that to share with your COIs, you can put the link to the proposal, to the text in here, so that they know exactly which one you are using. So I'm just going to upload one that I prepared, and here it is. Now let's start with the real work now for the proposal, which is the list of targets. You can add target, type a name, and hit return to resolve it. And if it's in Sesame, in Simbat, you will get all the information. You can fine-tune it, you can change all this, you can add magnitude information if needed. There is no point in deleting them. And you can, of course, add a comment which is just for you. Okay, if you have many targets, it can be fastidious to type them all one by one, so you can import them from a CSV file, and they will be loaded. And now we have them all. The CSV file is documented in the help, and I mean, it's really plain basic CSV. Oops, wrong one. Okay, no point. You know what a CSV file looks like. Okay, now, next is to define the various runs. So add run. A run is defined by an instrument. So for this case, I'll pick force to start with, which comes on a telescope. You cannot change that. You can choose the run type, read the call for proposal to know which one you want. The observing mode, I'll pick service mode. You can not adjust the period in case of a normal run. For monitoring or large program, you would have the choice. Proprietary time is something that you can adjust, and for this, I will completely relax it, so no proprietary time. So the run is defined by this instrument, mode, and then the constraints. And as Henri indicated, to get the exact constraints, we will have to iterate with the exposure time calculator, but we can start with a guess. And turbulence category, that's important, a change from a few periods ago. We used to request the seeing. However, seeing is not sufficient for adaptive optics and for VLTI. So we generalized to turbulence. The name of the category is the probability that you get that. So 10% is the 10% best, while any is 100% is completely relaxed. And in the case of force, which is a seeing limited instrument, the only parameter that goes into there is the seeing. So for this, I will start with seeing of 0.8 arcsecond or better. And I can add the run. Yeah, just the run name, we could call it something more that makes more sense. It's not critical. It's really just for you. Now, in this run, I will need to define the observing setups that are going to be used. And the observing setups are going to be used on all the targets on which you that you're going to include in this run. So I create a first one and I select the main mode in which I'm going to observe. And let's start with imaging, add. And then after selecting the mode, I want to specify the actual science observations that I'm going to perform. And so imaging, in this case, let's start with a B filter. You can add more. And so this would be a basic color of an object. In the same run, I can add a second observing setup. And in this case, it would be for spectroscopy. Same thing, I select the mode, and then I select the signs. You notice that the menu is not the same as for the first one, because after selecting spectro, I have only some possibilities. So the observations that you are going to request are predefined to be reasonable. I select here a grism and a filter. Again, the combinations that are offered are the only valid combination, so you cannot request a stupid filter that would not work with this grism. So, done. I've defined one first run. I will now define a second run for a different instrument, and let's call that IFU to observe with MUSE. I fill in the information, I relax the constraints to what feels reasonable at this stage but will need to be iterated. And I add the run that I need to populate with an observation, and for this one I need the narrow field mode with adaptive optics. And in this case, it's extremely simple. There are no parameters to be set, and there is only one type of observations. So to summarize, I've created two runs. The first one with two observations, one imaging, one spectroscopy. The second one, IFU with only one observation, one setup. Okay. Now, the next step will be to assign the targets to the run. And here, focus. It's important, and it's not obvious. So, if I select some target from my list, I can attach them to a run. So that means that 1, 2, 3, 4, 5, 6 targets. On this first run, I had 2 setups. 6 times 2, that means that I've just defined 12 observations. Each setup that we defined in the runs is applied to each of the targets. So again, 6 times 2, we have 12 observations. The second run, for some obscure scientific reason, I need only the first target. So 1 target, 1 setup, 1 observation. Let me go and see what we have. I continue in the menu. This time I'm in observations. So I have the two runs that I have defined before. I can deploy them, and for each run, I have the first observing setup with all the targets, and then the second observing setup, sorry, the first run with all the target, and in each target, all the setup. So let's focus on the first one. I can deploy to have all the details. So you see it is the same setup that we have defined before, but this time with all the details of exposure times. Same for the second run, which has only one target and one observation. So here comes the exposure time calculator. I know the magnitude of this object, so I can go to the exposure time calculator, as Henri has shown, and start populating it. So this is a galaxy, so I define a Cerseic profile. I choose the starburst menu from the spectral template. I fill in the magnitude, etc., etc. I go down. I leave the FLI and the air mass for the time being. And as a starting point, I say that I want 4 exposures to have 4 position angles. And let's start with 500 seconds. I cheated for the demo. I know it's going to work. I execute it. You have had all the details from Henri's talk. And I get a signal to noise of about 100, which is exactly what I need. So that means that for the science exposure, I need a DIT of 500 seconds, 4 exposures for a total exposure of 2000 seconds. Let me go back to the proposal. That means that I can fill in the integration time, 2000 seconds, that's the total, and the signal to noise of the order of 100. This is for the people who are going to review your proposal to make sure that what you are asking makes sense. Sometime in the future, we will have a direct connection with the new ETCs. It's not ready yet. When the instruments will be migrated to the new ETC, we will start making that link. Okay, that leaves you with the difficult question of the overheads. There are 2 methods to get the overheads. The first one is you go to the overhead table that is linked from the top, and you look for what you need. My recommendation is that you use a little spreadsheet where you collect all the information. So the preset, the acquisition, you compute the total for the telescope overhead. And so that would be 660 seconds. And then for all, where is MUSE? Yep. And then all the various bits and pieces to build your observation. So set up the guiding, set up the AO loop. I have 4 DITs. Each of them needs a detector setup and a readout. So that means I have a total instrument overhead of 500. So going back to P1, that means that I will put here the telescope overhead, 660 seconds, and here the instruments overhead, 500 seconds. All that is good. So I've populated the lower part. Now I can compute the total exposure time, and to do that I press the sum sign, which computes the total and updates the observation. If you're familiar with the P2 system, you could go and prepare an observation block. You really don't need to fill in all the details, but just select an acquisition, select the observation, and then here I have 4 DITs of 500 seconds. I press the update exposure time, and here at the top you see that the total exposure time is 33 minutes. That's my 2000 seconds. And the execution time is 51 minutes. Oops, I've done something stupid. That fits pretty well with what we had done by hand. Total exposure time is 33 minutes. And the grand total is 53 minutes and 40 seconds, while P1 says 51 minutes. It's good enough. If you go the P1 way, if you go the P2 way, you can store all the overheads in the telescope overhead. That also works. Okay, so you see that we still have an error message here at the bottom because this is adaptive optics. I need to add a natural guide star reference target. And to do that, I will type the name of the reference target here, HD, and I can select it. Okay, where does that come from? Careful, this is important. It comes from your target list. I had prepared my reference star in the targets that I have imported. If you need reference stars for adaptive optics, for any type of reference star that your observation requires, you need to add them to the main target list. You see that it appears, it appears as unused. There is no run for the HD 1234 star. It's because it is used only as a reference star. Okay, going back to the observation. So that means that the IFU adaptive optics observation is now defined. Let me go back to the force observations. And you could do the same thing. Go to the ETC and populate all these fields one after the other. Okay, and press the sum button and you get the result. Note the repeat here. Repeat means that if for some reason that you will explain in your justification, I need to repeat the whole observation, I can say it here and say that in total I need 3 times this. Now, let me do it quickly for this one too. And I need only 1. Okay, now the first one is ready, and you would need to do that for all the others. You have 2 options on how to do that. The first is you go and fill everything which is probably not needed to go into all details for all objects. So you can just specify the total in the blue box. And then in the justification, you say that you explained it for once and that the others are scaled from the one that you detailed. There is another way, which is the propagate button. Top right, you see propagate telescope time, and that will copy all the information that I've put for the first M77 target to all the others. Careful, it overwrites everything. So running, done. So that means that now all my observations have been copied from this model. If needed, you can go and adjust for some of them, but it really depends on your science case. Also, a nice feature that is worth noting, let's say that for this target, I already have the spectrum, so I don't need to book time for it. And so instead, what I can do is set the repeat to 0, and in that case, it's not accounted. It might be a good idea to put a note in the justification. So I will now go back to the summary, and most of the information from the checklist is already taken care of. You see that what is missing is all the text files. So I will cheat and go to one that I pre-filled sometime earlier. Oh, I thought I had one ready. Yes. Here it is. At the end, once you have filled all your fields, the red box is gone. The submit button appeared at the top right, and you are ready to go. You can submit the proposal. Okay. First, you sign, you certify that you have included the overhead and that you agree to everything, and you submit. The proposal is submitted. This is a real proposal, so if I don't do anything about it, the OPC will receive a demo P1. We probably don't want that. Also, important information, you can submit and desubmit as many times as you want. If I unsubmit the proposal, it's gone, which means it's not in the system anymore and I can edit. So in this case, I will probably leave it in that state. But this is something important when you work with your COIs. Try to get the proposal submittable and a few days before the deadline. You can always revert and make some corrections, but at least you are sure that you have something that's submittable. And then, final step, you have top right a PDF button that will create a good old PDF file that you can print and exchange and look at. Can be convenient. Good. Well, I think that's all I have the time to go through. And
great.
So
thanks,
conclusions, you can play with your account. Just be sure that if you submit a proposal, it's really submitted. Or just to play, you can use P1 demo. And let me stop sharing.
Thanks, Ollie. We have a few questions from the chat, which I'll go through. So the first question was, what about if the pointing is offset from the coordinates given for the source from Simbad or NED? Can you edit the coordinates manually?
Absolutely. What you retrieve from the server, from the CDS server, is to make your life easy. You are free to adjust the coordinates, to add some information. That's entirely up to you.
Great.
You can type it completely by hand. If your object is not in any catalog yet, you can type everything by hand.
Right. Richard Anderson, was your question concerning some typical settings for add observing run answered enough to your satisfaction, or like Ollie to try and comment on it?
Yes, thanks, it was answered.
Okay, great. So the next one from Stuart Ryder, P2 doesn't separate the total overheads into telescope overheads and instrument overheads as required by P1. What can we do about this?
Yeah, that's a pain, isn't it? My recommendation is that you stuff everything in the telescope overhead. Let me come back. So I go back to observations, and let's go back to the IFU case. Tac, tac. This is not the one I've shown before. It's a slightly different one. But so if you don't have the instrument, the details, you could leave this instrument overhead to 0 and put, how much was it? Whichever the value was in the total. Okay.
Is it possible to just edit the telescope time directly as well without filling any of the details in the in the telescope overheads, or you have to put something?
You can leave everything to 0. Okay, that is valid, and then you can type a total here. That also works. Okay, beware that if you do it that way, the details don't have any details. And so that means that you will need to explain how you get to these numbers using more words in your telescope time justification. And as usually that section is packed, you may want to put at least some of the information in the boxes here. Again, it's not, all this is just information, which means that it does not matter where the information is, provided that you are consistent.
Okay. And I think the last.
Eventually, we will have the connection. We will have the connection with the other systems to pre-fill in that information, but we are not there yet. It's actually not trivial.
P1 to P2.
Yes.
Regarding the NGS for AO observations, is there a way to select from a list of suitable sources depending on the science targets, mostly depending on distance from the science source and brightness of the NGS?
Not yet. Not yet. For those who are familiar with P2, in P2 we have a system to pick suitable guide stars. This will eventually be linked to P1 so that you can you can do it directly. It's not the case yet. To be honest, it's going to take a couple of years before we manage to get to that. So in the meantime, you have to find your guide stars using either P2 and OpsPrep or some other resources, and you have to add them in the target list. So we are working on it, but it's not there yet.
And the last question for the moment from your talk, is there a way to upload a series of observations, like importing OBs in P2?
No, it's not. It's not. The nearest I can offer you is if you have a proposal that you have already worked on, you can clone it, top right button, and make a copy of it, for example, in a different cycle. That can be very convenient. But there is no way to import or export OBs. For advanced users, Henri has mentioned that everything works with APIs. So that means that it is possible to create these observations and populate them using a script, Python script or something like that. We have somewhere an example documented on how to modify the exposure times, for example, but there is no import-export function.
Okay. Thank you, Ollie, and thank you once again to all of our speakers from this morning.